Hello guys, if you like my awesome gaming videos, my programming and web development courses, my editing courses and editing videos, and my tech talks and tech guidance, then you can consider subscribing to my channel and click on this bell icon to stay connected with me all the time. Hello everyone, welcome to my channel. So in this video I'm going to talk about the real use cases of integrations, and make sure you have some previous understanding of integrations and some pre-requirement for understanding this video. But most of the cases you will understand it even if you are a beginner student. And today I'm not going to solve any high quality and very high-end integration problem. We're going to just understand the use cases and why you use it and why it's so effective in daily life use cases, in physics, in economics, in mathematics, in rocket sciences, everywhere integration is really important. And if you understand integration, you can integrate it in your daily life. Even up to PhD students really need to understand it. Even if you're a researcher, you need to understand it. So integration plays a big pivotal part in understanding very complex mathematical data, any kinds of numerical informations or continuous data, all of this stuff. Okay, and you can calculate anything. Like for example, you can calculate any area of any shape. It can be circle, it can be triangle, it can be any equation formula, and it can be cylinder, it can be sphere, it can be anything. Okay, you can solve it with integrations. So it is really powerful technique and you must understand it. Today I'm going to talk about the integration. This is the sign that we use for integrations, and this is the limit. This is the lower limit, this is the upper limit. So these are the two things is really important. If you understand the limits, I'm going to talk briefly about the limits because it's one of the most pivotal part of this integration process. So let's go part by part. And why do you use it? We use it to find the area of anything, any function of x. And this function can be like y is equals to mx plus c. It can be any function. Okay, I'm just giving it for example. It can be for any equation, any function, you can do this. And this is just a simple straight line equation. You can do this for circle, for sphere, for cylinder, all of the thing. For any kind of shape, you can find the area of it. Okay, if you make sure you have the equation for it, and this is very important thing. And you need the limits, then you can find anything. And the second part is understanding the limits of equations and limits of integrations, which I'm going to talk briefly in this particular video as well. And we're going to find the volume. So let's get started. Today I'm going to start with y is equals to root over x. Y is equals to square root of x, you can also call it. Okay, so let's find it, and this is the main equation that we're going to solve. So let me draw this. This is the most simple one. Gradually I'm going to show you the more difficult one, more harder one, so that you can get the hang out of it. Okay, so this is really important to understand. So this is just a simple coordinate thing. If you don't understand coordinate geometry, you will have some problem understanding it, but most of the thing are really easy. And suppose this is our x-axis and this is y-axis. I hope you know everything. And this is the center point, with it starts with 0. I'm going to draw this equation y is equals to root over x. If you didn't watch my previous video where I talked about how to draw this different kind of equation, you must watch this video, which will be really helpful for you. Like this equation is like that. This, okay, gradually it is increasing and then it is steady increasing. It is not increasing that much. Okay, so this is the look of this equation. And it should be always positive side, because root over square root of x always gives you a positive output, because you cannot put negative x, a negative value inside the x. Okay, so this is the variable, and based on this x variable, y would be dependent. So if you draw this, it would be similar to this. And suppose, and I just keep it, this is the value 2, this is 1, this is value 1 in the x-axis, this is the x-axis value 1 and 1 and 2, and this is 0, 1 and 2, if you understand the coordinate geometry. So how can we get the area of this? We don't have any formula. Okay, it is not triangle, it is not circle, it is not anything that we know. It is completely different thing. We can't find the area of it. This is quite impossible. But in integration we can easily do it. How? If you just see this, if you just say that this is a simple rectangle shape, like as you can see, this is a simple rectangle. If we add all of those rectangles, if we add all those straight lines, okay, if we add all this, like this one, all are rectangle shape. If we add all of this stuff, this is all simple shape, and we know the formula for it. Okay, we can get the area very easily. Now one thing is very easy. If you know the equation, you can easily find the area very simply. Now let me show you how we can do this. Here I'm doing it. So this is the integration sign, and this is the limit. How many times you will do it? When you will stop and when you will end. You will start from 0 and you will end at 2, because it stretches at maximum 2 value. So here it ends. This is the end. You will start from 0 and add this stuff, and you just continue adding all those straight line, and you will get the total area of it. Okay, this is the rule. So it will start from 0, end at 2. So this is the limit, where the 2 is your upper limit, this is where you end, and 0 is your lower limit, where you will start from. It's for any purposes. For circle, you will start from 0 up to radius r. Okay, so I'm just taking this into action. Then what you need, this is your integration part. Then you need a function of f of x and dx. Dx is this part, this small distance between this rectangle to this straight line to this straight line. The difference is dx. So if you add all of this stuff, this is small part, dx is the very small part. This is very small, near infinity small. If you add all of this stuff from 0 to 2, you will get the total area. So dx is really important here, and it's along x-axis, so it is dx. If it is along y-axis, it should be dy. Okay, so we need to find the fx. So we already have the fx. So if I just calculate it, this fx is nothing but y is equals to root over x. 0 to root over x dx. Okay, so what you need to do, you just need to calculate. So we can write this thing, x to the power half dx. Now we can get this formula. So this is very easy formula for you. So now as you can see, it's in simple formula, it's x to the power, this is just an exponent formula. You can just add those stuffs. Okay, x to the power half plus 1 divided by this part, half plus 1, and you need to have the limit 0 up to 2. So this is coming from the formula. If you just consider 1, you just need to add those power, half plus 1 divided by half plus 1, this power inside this, and you put your limit. Now if you calculate it here, it's like x to the power, if you x to the power 3 by 2, and if you calculate it, it should be also 3 by 2, and put your limit. If I come here, it should be x to the power 3 by 2, and if we just put 2 in the upper side, this is 2 by 3, and 0 to 2. Now what do we have here? We have 2 by 3, x to the power 3 by 2, 0, 2. Now here you put the value 2 by 3, for this is definite integral. Okay, so it should be 0 by 2. Okay, so if we put the value of x is equals to 2 here, 2 to the power 3 by 2 minus, if we just put 2 by 3 and put the value 0 to the power 3 by 2. Anything to the power 0 by 2 is actually 0, so this part is all 0. 2 divided by 3 times 2 to the power 3 by 2, and it is 2 to the power 3 by 2, and you can just calculate by yourself and see what the value comes. Okay, and it should be pretty simple for you. So this is our actual output. So this is very simple. If you just put the value like 3 here, then you need to put the value of 3, then it should be 2 by 3, 3 to the power 3 by 2. If you put the highest value 4 here, then it should be 2 by 3, 4 to the power 3 by 2. So this is how your answer should be like for these particular equations. So what we did, we just put the value of f of x, this is the function value, and dx. For each individual, this distance is dx, and this distance is very small distance, and if you add all of this stuff up to 0 to 2, you get the whole area. Okay, and you just put the formula of integration, normal formula. This is the first formula of integrations, very simple. Add this power and divide this by this power and put the value of these two inside this variable. Okay, this is very simple stuff. So this is how you can get the area of it. So now we're going to calculate the area of the triangle using the power of integration that we have just learned now. So we're going to use this formula. This would be our output, half times base times height. So this is our height of this triangle. This is h, and this is the base. Okay, so we're gonna integrate it from 0 up to b. Okay, so this is the equation. Now how we can build this stuff? We need to use straight line formula, which is, if you just know it, recall it, y is equals to mx plus c. But here c would be 0 because this is the y-intercept and it is starting from the center point, so c would be 0. So normal equation, y would be mx. Now what is the m here? Okay, so this is the thing that we need to find out. So if you want to find this m is nothing but height divided by base. This is the rise over run. So this is the slope. So m is equals to rise over run. It should be m is equals to height divided by base. So rise over run, simple. So this is our equation. And if we want to find another equation, okay, these are all straight line. This should be this straight line, this straight line, this straight line. If we add all those thousands straight line and from 0 up to b, we can easily get the total area of this triangle. Okay, so we need to all calculate all those straight line. Okay, we need to add all of those straight line from 0 up to b, and if we put the value here, it would be y is equals to m, which is h by b times x. Now this is a function of x. Now we can easily calculate the area. So what would be the area? It should be 0 to b. So this is our upper limit and this is our lower. So this is our lower limit, this is our limit, because we're gonna calculate up to 0 to b. So this is our upper limit and lower limit. Okay, then we're gonna use f of x and dx like the previous equation. Okay, now what is the f of x here? F of x is this equation, so we're gonna put it. We can't put y here, we're gonna put the result, which is this. So 0 by b, h by b times x dx. Now h by b is constant. Okay, h by b is constant. This is the slope. Okay, so we're gonna put it on the other side, outside of this integration. This is the rules of integration. If there is any constant value, the proportion or any a constant value, like pi is also constant. If you put any number value, this is also constant. We're gonna put it outside. So the remaining is x dx, and the integration of x dx is very simple, which is x squared by 2. Okay, so we're gonna use this thing. So if it should be x squared divided by 2 to 0 to b, and now we're gonna put the b inside this is by b, so it should be b squared divided by 2 minus, this is the formula minus of this integration, and we're gonna put the 0 here, so 0 squared divided by 2. So this is all 0, so total it should be is by b times b squared by 2. If we calculate it, this is b, so b times h divided by 2. So height times base divided by 2. This is our answer. So this is how we find the area of this triangle using this simple straight line equation. Because when we are adding all the straight line, they are all straight line. We are just adding all the straight line from here to here. Okay, from 0 to b. So they are all straight line. There is other method, like if you just take this triangle, if you add all of the straight lines, all of the straight line from 0 to p, if you add all of this stuff, you can also get the similar result. Okay, so this is the same concept here. So now we're going to understand how we can find the area of a circle using the integration technique. This is a very simple circle. We know the circumference of a circle is twice pi r. Okay, so this is the circumference of the circle. Now how we can measure the area of circle using the integration technique? So we need to set up it first. Integration is very simple, but the setup is complicated for some people. The setup is so super important. So how we can measure it? Suppose we're gonna take a circumference from here to here, okay, and make sure our distance, our radius, the small circle, its radius is like x. Okay, so we can consider for the small circle the circumference is twice pi x, and this is not only the first circle. You need to just add it for multiple time until this position is complete, until you reach your radius from 0 to r. And you need to make one more circle. I'm just adding one more circle and one more circle and one more circle. So there can be thousands of circle up to 0 to r. So as you can see, I'm just giving it an example that how you should draw it. It is like this and this one and this one and this one and this one. Okay, from this to this. Okay, from this position it should be very smaller. I'm just showing it for demonstration purpose that it should be like this, and it should have a simple radius which is x. For each individual circle from 0 to r, you need to add all of those discs of circle to get the total area. So this is how you use the circumference method. From 0 to r, add all of those small circles up to radius r, so that we can get the whole circle. So what should be the area? So let me put the limit. It should be definitely 0 to r up to the radius of your circle, and you need to use the twice pi x. This is your each individual circle's circumference, and there should be thousands of circle here. So twice pi x dx up to 0 to r. From this position to this position, you need to add all of those circles circumference. Only then you get the total area of this circle. Like this, you are adding all of this stuff. Finally, you are getting your ultimate result. So that's why 2 pi x is coming from this circumference of the smaller circle, and dx is very small length. You can just consider this is your dx. This is a smaller part. So what integration does, it takes all the smaller parts and add it, and the differentiation is the opposite of it. It takes the bigger part and it's divided by a smaller portion. Okay, so integration and differentiation are complete opposite of it. So twice pi is the constant. As you can see the previous part as well, I talked about that the twice pi, any numeric value, any proportion, all of them are normally constant. So you need to keep it aside. You don't need to calculate it now. We just only need to calculate what is inside the dx. It should be the function of x. Okay, so the x dx, so twice pi, and x dx integration is x squared by 2, and it's up to 0 to r. Now I need to put the value of r, and it should be r squared by 2 minus 0. So twice pi r squared by 2 is gone, so pi r squared is our area of the circle. So by using the simple integration formula, okay, we can easily put the equation, which equation you want. You must have an equation. If it is given like y is equals to mx plus c equation, then you need to put the value here. We need to calculate the slope, and we need to use this kind of thing in whatever format. If it is given like circle equation is x squared plus y squared is equals to r squared, then you need to put the value here. But I'm using the circumference method, so that is our equation is twice pi x dx. We put all of those things, integrate it in terms of x, and put the value of our limits, and you just get it. This is so magical, and the setup is important. That's how you set up this part. This is the most important thing that you need to consider when how you set up it like a boss, so that you can get the proper result. This is a very simple equation, this is very simple math, but when there would be very complicated stuff, to set up all of this thing would be really hard. So setup is the ultimate thing that you have to understand, how you set up this equation. The integration part is easy, but the setup is very thinking part. So this is the part where you need to think a lot, understand it, how you generalize it. I will get the output, I will put the limit, I will calculate each of the disk, and from which part to which part you're going to add all the disk and get the final output. And this is the thing that you need to master. So now this is the fun part, where we're going to find the volume of cylinder. Previously we used to find the area of circle, area of triangle, area of some equations, all of this stuff, or area under the curve. Now it's time for understanding how to find the volume. So if you just understand what the volume is nothing but the length times height times the base. We need the depth. You can understand this height is this height. Our total height is h of the cylinder, and it has its radius as well, as you can see. So this part is actually the circle. Okay, so you have a circle as well inside this cylinder. But for cylinder, to understand the volume, you need to find length, height, and the base. Okay, so if you just take this as a simple 3D object, it has its length, it has its height, and it has its depth, and this is its depth. So depth, in case of B, you can take the depth. You need three things: length, height, and depth. We have the height of the cylinder is h. You already got it. So now we just find out which method we're gonna get the volume. First we're gonna find the area. Okay, so then we can integrate it up to 0 to h, up to this position to this position, till the whole height we're gonna use it. So if you want to find the volume, this is our limit, should be 0 up to h. Up to 0 up to h, we need to integrate all of the disks. So if I show you one more object, as you can see, this is a simple cylindrical shape thing. So as you can see, it's a circle. Inside all of those things is a circle. If we add all of this stuff, this is one circle, this is one circle, this is one circle, up to 0 to h, so this is its height. Up to 0 to h, if we add all the circles inside this, okay, we're gonna get it. Now if we just look at it, a simple circle, this is the slice of simple circle, or this is the simple slice of this cylinder. So what we have in the upper portion, we have the pi r square h. It has its radius r, and its area is pi r square. Okay, and it has its depth, and its depth is, you can say, dy. Okay, so if I just think it like this way, so this is its radius, and it has its depth, which is, you can say, dy, because it's along the y-axis. As you can see, we are integrating along the y-axis up to 0 to h. So this is along the y-axis, so this depth is actually dy. So we are already getting the a of y, because it is along the y-axis. In the previous example, it was along the x-axis, but here we're integrating along the y-axis. So ay dy, ay is the area here, and dy is depth. Okay, so area times depth is actually the whole volume of each individual cycle. Okay, so each individual part. So this is one part. We need to add multiple, we need to add lots of it. Okay, so another part, here is another part, here is another part, and it has its depth, it has its depth. There can be thousands of these circles, and its depth is multiplicated up to 0 to h. If we add all of this area and their depth, and we're going to integrate it up to 0 to h, then we get the volume. So the formula for volume is area times its depth. Okay, so this is the total volume. This is only simple this part's volume, not the whole part. So we need to add it for thousands of time for each individual this circle, and each of them would have their own radius, and that's why the radius is constant, because radius is not changing here. So if I just write it here, it should be 0 up to h, and its area is of this circle is pi r square times its depth. So that we can get the volume, we need to add the depth as well, pi r square dy, and we're going to integrate it up to 0 to its edge, from this position to this position along the y-axis. We're going to add all of those disks together. Okay, then we can get it, and each disk have their depth dy and their area. So it's a and multiplicate with its dy, its depth. So total we get the volume. Okay, so we need to keep this pi r square outside. Now it has become a constant because r is constant, because r is not changing. For each circle of each these slices, r is always the same. This is for cylinder. Okay, for cylinder this is always the same. Then up to 0 to h, we can integrate dy. So this integration is very simple. This is only, if we integrate dy, we will get only y, and our limit is h by 0. So pi r square, in terms of h, just put the value h inside this variable, which is h minus, now put the 0 inside y, this is 0. So what we get, pi r square h. This is how the h comes, because you're going to do it along the height of this, along the y-axis. If it was like in the x-axis, if it was like this, if it was like this, then we had to do it like along the x-axis, from the minus, from a to b, suppose. Then we used to do it like this, and this should be the height of this this cylinder. Okay, so for cylinder we normally do it along the y-axis. Okay, so that's why it's coming in terms of y, dy. If it was like this, it should be in terms of dx. Okay, but now it's in terms of y, that's why all the thing is along the y-axis. It's ay and dy, all the depth is along the y-axis. As you can see, it's along the y-axis. The depth is along the y-axis, the area is along the y-axis. We need to do it all this in terms of y. So this is very important. Should it be in terms of x or in terms of y? Different kind of scenario, it can be different. Okay, in the previous example, that's why I showed it in terms of x. Now it is completely different. It is in terms of y, because it's along y-axis. That is the simple thing. And the limit, how we put the limit is also all the same, from which position to which position you are adding all those disks together. And why the r is constant here? Because r is same for all the disks. It's always same. Okay, so that's why you don't need to integrate it. We just normally integrate this dy part. So this is very simple, and we're gonna get the pi r square. This is the volume of this cylinder. So if you have to understand this or using this integration. This is very simple stuff, and it works for any shape, any equation, any type of data. Okay, so that's the part. This is the power of integration. Okay, so till that, take care, bye. See you in the next video with more awesome and beautiful content.